and the size of this image is 803 megabytes. So difference is really big. And open localhost 19T, so we should have this application running. Hello guys, in this video we'll talk about Dockerfile, and we will use multistage Dockerfile for Go application. And by using this multistage Dockerfile, we can reduce the size of the final image. As an example, we will use KN project repository. In this repository, in this project, I use Docker and Docker Compose in a couple of places, and especially for backend applications. And our example will be based on this be-st folder. Be-st is one of the components of this project. And our example will look like this. So basically, our goal for this video is to build this image, run application within this image, and then finally compare the size of a final image and see what was our win by using this multi-stage Dockerfile. I have this repository locally. You can also get this by cloning this this project. You can use this link for git clone, or you can just basically download zip. And then in a folder called be-st, this is within root folder, so it will be be-st. There is a Dockerfile, this one, and this is an example of multi-stage Dockerfile. As you can see, we have two from statements, and they are based on different Docker images. First one is based on Go language, because we need to have Go tools to build our application, to build our Go application. And in the second one, we use base Alpine image. We can see, I think I have it in my browser. So this is base and official Alpine image, which is only 5 megabytes in size. And we will use this as a final stage in our Dockerfile. So let's go through this file. So basically we use, as I said, the Go language, Golang Docker image. Then we create a folder called called app, and then we copy our source code. We copy only this source code. We run our tests. So I use makefile for this, but this is probably another video, but we can already take a look. This is our makefile, and there is a test command. This one, it's a quite simple one. And if our tests are successful, I add this version and then build the image. Build the source code, compile our Go application basically. So it is go build command, and I expect that if it's successful, at the end I will have this file, this binary file. And within our second image, basically what I do, I start another, let's say, stage or container. So in terms of Docker, it's layers, but in this layer, it's like empty layers. They don't have any shared files. And since this output file was in my first stage, I need to copy it. So this is our second command. And in a copy command, we can specify name of the stage. So this will be from this one. So by using this syntax, we can give name to the stages. And then I say that, so basically this command means that copy this file from builder to this container, to this part, to this stage basically. And this is name of the file, and this is name of the directory or folder. And as I said, we expect that we already have this file here. So if there is something wrong, this build will be failed, so we will not get to this point. And now we can run this. So to run this application, I already have these commands, but let's type it again. So I am in the same directory. So what I do docker build. I specify as a point of the build as a current directory, and then give a name, which is, so I use this kind of naming. It comes from our project, which is KN, so please take a look. This basically means KN, backend, and name of the project. We are now in a ST project, which is service directory project, and we will see it running in a second. And I give a latest tag. So by executing this command, I already did this execution, so it was quite fast. But for you, it can take a couple of seconds. And then when I have this container or image ready, I can run it. So I should have example run command. So for now, let's just run it by a name of the application. So we know that within our container, we should have this file. And of course, I need to specify name of the image. So basically, it's a bit confusing because our name of our image and name of our application is same. But this one is the name of the image that we built previously, and this one is the name of our file. So if you go to the source code, this is a file. So this file. Let's execute this one. I should say that this file is a Go application, a Go binary file, and it contains web application. And for this web application to work, it requires some environment variable. To dive into the details, you can check this file here, and then this file here. So in this file, it expects this environment variable as a port. So let's specify it. So I will add one more step, which will be set this port. And this port basically says that when you run this application, run it under the 9080 port. This port also comes from our KN project. Please take a look for details. But for now, I will just run build again because we edited our Dockerfile. So I need to save and then run. And then I can run. But there is one difference, that since we now execute our web application with a port, I need to specify port to be exposed. So basically, internal port is this one, and I say that on my host, I also want to have this application on the same port. And then the rest part is the same. So this is name of our image, and this is name of our application. So let's run and see. So now we can go to the browser and open localhost 9080. So we should have this application running. So this is output from the application. It's a basic, very simple JSON file. And if we go to the main Go file, you will see that we actually execute a web application that returns in JSON. So output is correct. And that's how you use multistage to optimize size of the container, size of the image. And now let's see what we optimize. So basically, if I go to the Docker images, I should see name of this image. So this is our image. It says 33 minutes because I was testing this time ago. And you can see that the size is 30 megabytes only. But let's just imagine that we don't have this multi-stage, we use Go language. So basically we don't use the second part, but we use only this part. So this image, and the size of this image is 803 megabytes. So difference is really big. And if you compare this Alpine is 5 megabyte. So, but our final size is 13 megabyte. That means that our application adds another 8 megabytes, 8 plus megabytes, which is quite reasonable. So it is really optimization. If you talk about big project, and within this project we have a couple of Go applications or one big Go application. So any this amount of megabytes quite good for this kind of applications. So that's a win that we get. So if you want to go to know more details about this usage and about other usages of this multi-stage Dockerfile, you can take a look to the another folder, which is BSC folder. And in this folder, let's take a look at the final file. yeah, I have pull request with an updated one. So in this pull request, I add other Docker Compose. I add other containers, so, and as a result, I get much bigger Docker Compose. So reducing the size of this image really important when you have final deployment. So please take a look at this repository. And for now, that's it for multi-staging Dockerfile. Thanks for watching, and see you in the next video. Bye bye.